This is Math 3 2.1 video notes. That's Math 3 Unit 2 Lesson 1 video notes. And today we're doing homework notes, which is a little different, which means you should have your Unit 2 packet out. We're going to open up to worksheet number 1, and we're going to do one of the homework problems for our video notes. So you can put right here, number 1 is homework notes 2.1. All right, so when you take a picture to turn this in, this is all you're going to be taking a picture of, just this number 1. The rest we will do in class as an assignment. Okay, number 1, state the open intervals on which f is increasing. Open intervals means parentheses, we're not using brackets. Open intervals, open intervals. Now, you read a graph, and I've said this to you before, you read a graph like you would a book, from left to right. So I see the graph here, and then the graph changes direction there. So I'm going to cover this piece. From that point to that point, walk like you're walking on a hill. That would be walking uphill. Uphill is increasing. And then you go over here, and you're like this. You're walking downhill. Downhill is decreasing. Okay, you've done this in Math 2. In Math 2, your teacher may have taught you to do this. Everything on that side was greater than, everything on that side was less than, and you did inequalities. But now we're doing it in interval notation, so I'm not going to put those markings there. But we do have a left half and a right half. That left half is increasing, and that's what they're asking for here. When is it increasing? So at what x value does it start to increase? And what x value does it stop to increase? So it increases here 1 to -3, but remember it said open, so even though there's a closed, I'm still using parentheses, comma, and then it goes over 1 to 3, it stops at +3. So I don't care how high it is because I'm looking at increase. And when I do increase and decrease, I'm always reading the x-axis because I just said you read it from left to right. So the only time I'm going to be looking up and down is for the range. For domain, I'm looking at the x-axis. For increase and decrease, I'm looking at the x-axis. And if they ever ask when the graph is constant, same thing, I'll be looking at only the x-axis. All right, because I read from left to right. So -3 is where it starts to increase, +3 is where it stops increasing, so -3 to 3. Okay, once I hit the 3, the x value of 3, I start to decrease going downhill. So from 3, remember open parentheses, open intervals, 1, 2, 3, 4, 5, 6, 7, so 3 to 7. All right. That's it for increase, decreasing. Okay, now it's asking for domain and range. Now we're getting back to our brackets. When they're asking for domain and range, we use brackets when necessary, parentheses when necessary. Okay, domain, just like increase, decrease, you go from left to right. Starts here, ends here, and there is no open circles I have to worry about. So I would say -3 for domain. I would use a -3 with brackets up to 1, 2, 3, 4, 5, 6, up to 7 with a bracket because there's open circles on both. All right, range, now I'm reading the y-axis. Range is the only time I read the y-axis. Lowest point to the highest point. The lowest point is 0 and it's closed. 1, 2, 3, 4, 5, 6, highest point is 6 and it is closed, so a bracket. All right, I use parentheses here because it said open interval. All right, state the coordinates of any relative minimum of f and state the coordinate of any relative maximum. Relative means in that area. For example, I'm going to look down here. That is a low point, but it's not the lowest in all because this arrow here goes down forever. So that is not the minimum, but is a relative minimum, meaning in this little area here, that is the lowest point. So when it's talking about relative, it's talking in that general area. Okay, is there a relative minimum? There is none, because when you're looking for max or mins, you look not at the endpoints. The endpoints don't count as max or mins, only everything in between. And looking at everything in between, there is no lowest point. It goes up, highest point, comes back down. Again, this is not a relative minimum because it's not the lowest point when you look right and left. There's no points to the right. There is to the right, but not to the left. Here, it's the highest point to the point on the right and the highest point to the point on the left. So that is a relative maximum. And it says state the coordinates as an ordered pair, 1, 2, 3, 1, 2, 3, 4, 5, 6. And minimum, there is none. There is no relative minimum. This would be a relative minimum when you're working on this problem, and that would be a relative maximum, but on this one there is none. All right, write a piecewise defined function f that accurately represents the graph of f shown above. Okay, two-pieced. So I'm going to break it up here because that's the most logical place. It's not the only place, but it is the most logical place to break it up. So that's where I'm going to. And I'm going to have f of x equals, and here's my bracket. Again, I like to read from left to right, so I'm going to use this graph first, and I know it's going to be if x is in between what two numbers? 1, 2, negative 3, and 1, 2, positive 3. Because I'm graphing, well, I want to find the graph of this line right here between negative 3 and positive 3. Okay, so what is the function? It's a line. I am going to use that point as my start point. Okay, y equals mx minus h, no squared, plus k. If that's my endpoint, it goes 1, 2, 3 to the left, and it doesn't go up or down. So y equals mx plus 3, and I'm going to put plus 0, but I'm not going to use it in my final answer, and up 0, 0. M is your slope, up 1 over 1, up 1 over 1, m equals 1, y equals 1, x plus 3. I don't even need the 1 there. You could write it, it's up to you. You could just write x plus 3. If negative 3 is less than x and x is less than 3. We'll talk about brackets, about equal bars in just a little bit. Okay, second line here. It goes from 1 to 3. So if x is greater than 3 and less than 3, 4, 5, 6, 7. So it's in between 3 and 7. Again, we'll talk about equal bars in just a little bit. Okay, I'll do my work for that one over here. Y equals mx minus h plus k. And on this one, I'm going to use this as my start point, and that's 1, 2, 3, 4, 5, 6, 7, right 7. And up 1, 2, 3. Y equals mx minus 7 since it's right 7, and then plus 3 since it's up 3. And then slope, I'm just going to count. It looks like it goes through every corner, but maybe not. No, it does not. So I'm going to count from there to there. This one here, it went through every corner. Can you see that? And if not, and you counted up 1, 2, 3, 4, 5, 6, right 1, 2, 3, 4, 5, 6, you would have gotten 6 over 6, which still reduces to 1. Okay, so here I'm going to count 1, 2, 3, 1, 2, 3, 4. So m is up 3, left 4, so negative 3/4. So y equals negative 3/4 x minus 7 plus 3. Negative 3/4 is the slope, and I don't put y equals on both of them because the f of x is right out front. And you only write that once, and then squiggly brackets and your function. Okay. All right, so this is it, and let's talk about our equal bars. All right, This first one is closed, so I'm definitely putting a close there. Now, this second one is closed. Now, remember we talked about like one of them's closed and one of them's open as long as they're not both closed. So you would not put an equal bar there and an equal bar there. You can put it on one of them, but not both. So I'm going to erase that one, and that would be okay. Now, if you wanted to, you could leave it there and erase that one, as long as one's open and one is closed. We'll talk more about that in class. Now the last one is closed, and I'm just going to close it because the first and the last don't overlap with any other lines. That middle dot's the only one that overlapped with the previous. There's a 3 there and a 3 there, so only one of them. Again, you could erase that one and leave it there. It doesn't matter which one you put it on as long as it's on only one, but for sure one. All right, that there is your answer. Okay, that's it for this lesson. In class, we'll do numbers 2, 3, and 4 together.